Yeah, good.
So we're Team Rube, so we did a combination of two things. We wanted to make a Rudy Goldberg machine, and I wanted to try and solve a problem that I've been having for a very long time. So the problem space that we were trying to address is quite major in a specific sense. As an electrical engineer, for me to go along and do things, next slide, when I want to go program something to communicate different things, I have to go along and specify all the protocols and everything else. Now, with internet, you get to do that automatically, right? So the header and the body request or whatever else, that's all there for you. Now, someone spent years, like the internet's been around for 40 years at this point. They've spent 40 years trying to develop those protocols, and that's fantastic, don't get me wrong. But when you get low level, so click next slide. When you get more lower level and using Arduinos and everything else, stuff like PWM or SPI bus or whatever else, you have to know what they do and you have to understand what you're trying to send and all that jazz. So next slide. Wait, is it one more probably? Yeah, okay, sorry. So in a context of an actual real application for myself, I might want to connect like an Ethernet adapter or whatever it is. So I'll use SPI in the top corner, or I say I'm working on a car, I want to use CAN bus, and CAN bus is another type in serial. Sorry, now you get back that. Yeah, so what you have to do is you have to do something like this, where you have a ton of just slides and pages. This one's about 100 something long that I have to do for a different project. And it defines every single bit and every single byte, and it takes absolutely bloody forever. So the next slide. So what you kind of end up trying to have to achieve is you have to represent the hardware in your head, but actually make it so all the software sort of integrates and everything else. Next slide. So what I tried to set out to do was go along and make a system to go do that for me, because I don't want to spend another 100 hours trying to do this for me. I want to click a button and have it do it for me. That's kind of point of programming. So these are sort of general models of how these systems interact, and it's not too important. So basically it's serial. Serial is the one we're going to work about here. That's what we've actually done for this one. So you go next slide. So you can represent this as a series of nodes and a series of communications. This is all graph theory, by the way, so I apologize for anyone that hasn't done a whole lot of maths or has forgotten high school or whatever. Next slide. This can then be represented as a series of connections to the physical interlinkages, and each of those signals actually represent it as a 3D net, because you can't represent it as one way. This is all the stuff that I was working on the whole hackathon, I should say. Next slide. Every single device is actually like an endpoint, and every single communication point is still as a subset of a device. You just got no information about it, so you can then refine it. So you go next slide. You can start going along and doing pretty complex and awesome signal analysis and everything else, and actually make it so you can define which way direction flows and everything else. Next slide. The point of all this is that at the end you can make a mathematical model out of this, which you need to go along and do the code for. And this is sort of saying about like for n number of devices, so if you've got like 100 devices connected, you can go along and say that, oh no, they still work out, because like you just keep adding more on or whatever else. Next slide. And then from that you have to make a way so they all interconnect, because if you just go along and say, I want 100 of those, depending on how the wires connect, it could all change. So next slide. So coming back to the software side, now so that defines the hardware side. There's a ginormous JSON document that sort of goes along and has it all described, and it's not pretty, so I didn't put it up there because you don't need to see the code about it. So back to the software side of it, we need to go along and actually sort of define how this sort of interacts, because now we have a hardware layer, we can sort of inform the software layer. So every single point that you want to go send data to is called an endpoint, right? So it's an end of something. So be it in HTML, be it in websites or whatever else, you want to send something somewhere. And each one of those has a particular action. So whether you're building like stuff I'll show you later, something that can send some data to whatever else, they're all in action. They all have some sort of data. And lower level, you have to define sizes and things like that, so that's why that's there. And again, some examples like you might want to get data off, set some motor speed or whatever else. And endpoints might be a whole computer, or a router, or a server, or whatever. In CAN bus, this is what you might be expected to actually produce from it, which is an absolute pain in the ass, because you've literally got ones or zeros, and that's sort of stuff your computer runs on. Next slide. So what my software has to go along and do is understand what it's doing in terms of software and represent it in hardware. So that's kind of an example. So the header will be like device ID, we want to send it to, data to follow, any checksum for data for integrity. Anyway, that's all signal stuff that gets more complex. Next slide. And then in the end, it should represent this again. I didn't finish off the software side of it for the hackathon, which is a great shame. But the hardware side's fully done, so I'm going to continue to do this myself and do software. Anyway, point being, with the hardware side of it, we want to actually try and implement this for the serial side. So we're going to use the TINC to talk to our stuff, and I'll let Chris take it from there.
The idea for this system that we built, tying the hardware side of things along with the sponsors application, came from originally wanting to build a Ruby Goldberg machine, essentially doing something simple through a really long and convoluted process. Originally we had all these together but in a slightly different order, and then we realized with a little bit of shaking around we can actually make something useful. So essentially it's a demo of taking some data from some hardware, posting that, writing that onto a blockchain, then displaying that on a front end as well as sending SMS alerts. So examples of this could be, say you're sensing stuff in factories and something's going to overheat, let everyone know, or making cups of tea and things are cooked, and things are done and you want an alert. We'll give you a demo and then we'll talk about some of the other stuff. Demo time. So, interesting. Okay, so this is our front end here, and this is a temperature sensor right here. So at the moment, is this one the hot one? Yep. So I'll put this in this cup of tea here, in this hot water here, and you'll see the temperature go up. And as it goes above 50 degrees, which is the threshold we set, just arbitrary, Kai should receive an SMS. So you can see the dotted lines at the end there. There's actually like a regression going on there, which is predicting the next temperature that it will be. Now Kai should be receiving the SMS sometime soon. There we go. And then as it comes out, you should receive another SMS to let him know that it's gone below the threshold. So now we'll have Noah come on to talk about the blockchain aspect of it.
So for this project, we wanted to kind of, as we would get the data, we wanted to upload it to the blockchain to kind of, for a few reasons really. One, we thought was that when you upload something to the blockchain, it becomes immutable. So it really enforces data integrity, and so in maybe less so in temperature sensing, but maybe in other applications, having data that's unchangeable is quite, a real world application. It would be pretty important. So, maybe we thought of some examples where, maybe government has to share certain public data. Sharing that to the blockchain would mean that no one can go and change that data, and, kind of, it really just means it's kind of a whole more, I guess, secure network. Also, I guess with Status and Embark and their sort of frameworks for the Ethereum blockchain, you're able to work with smart contracts and kind of use all different types of data and upload that to the blockchain. And of course, you can have private blockchains, which in this case we were deploying a private one because obviously we didn't really want to work on the real blockchain, but you can work privately or publicly with that. So yeah, okay. That's.
All right. So all I did was I just checked the current temperature and the previous temperature before that, and had it so it would send a message through the AppyDays Communication Management API to create an SMS that would describe exactly what's happening. Yeah, that's pretty much all it is.
Cool. The website we showed you is actually currently live, so you can go to that at its IP over here. And thank you for listening.